First, to quickly finish up the last example we worked on yesterday. So this is the one with the water flowing out of the pipe. We did our right Riemann sum. We got our approximation. But the second part we didn't quite, I think we said verbally, but just to make sure that we know how to answer this type of question. So this is an interpretation question. Remember the acronym NUT to have all of the parts with derivatives. Very similarly with accumulations, we need our number and our noun, like what's the context of the problem. We need the units and we need the time. Although in this case, it's going to be a time interval instead of an instant. So we could say something like over 0 to 24 hours, 255 gallons of water. What's it doing? Flows out. Okay. Flows out of the pipe. Okay, so I have my context, which is the water flowing out of the pipe. I have my units, which is gallons here and hours here. I have my number, which is 255, and I have my time unit. Okay, so quick summary of all of our numeric approximation methods. Okay, so we have three different Riemann sums, left, right, and midpoint. So we can say for a left Riemann sum, we're going to use the left endpoint of each subinterval, not the input value, but not x or t value, but the output of the function at the left endpoint of each subinterval becomes the height of each rectangle. So we can say the height of each rectangle is the value of the function at the left endpoint of each subinterval. Subinterval. Okay, so this is going to be at the left endpoint of each subinterval. Okay, so then for a right Riemann sum, I'm not going to rewrite the whole thing, but I'm going to say here it's going to be at the right endpoint of each subinterval. And for midpoint Riemann sum, the height of each rectangle is the value of the function at the midpoint of each subinterval. So either left endpoint, right endpoint, or midpoint. Okay. And then the other numeric approximation method is the trapezoid rule or trapezoidal sum. You may see both terms. And the idea here, this is not a Riemann sum because it's not technically a rectangle, but the idea is that we are using trapezoids that are, now we tend to think of a trapezoid like this, where the bases are parallel and those are horizontal, but we need to turn it sideways because we're going to be looking at things like this. Okay. So these are all trapezoids. Turn your head sideways if you need to. Okay. The bases, the parallel pieces, are these. All right. The area of a trapezoid is we need to find the length of this mid segment, which is the average of these two bases. So that's base 1, that's base 2. So it's going to be B1 plus B2 over 2. So average the bases, okay, to get the length of the mid segment, times the height, which is the distance between the two bases. All right. So in terms of our trapezoids, the heights are going to be this way. Okay, they're going to be the horizontal distances between the two bases. And then the base values are going to come from the value of the function at both endpoints of each subinterval. Okay, so hopefully that makes sense. Let me know if it doesn't. But with a trapezoid, with the trapezoidal sum, basically we find the area of each trapezoid and add all of them together. So for a trapezoidal sum, find the area of each. I'm just going to put sideways in parentheses. Not that trapezoids have to have an orientation, but this will help us remember. Okay, sideways, trapezoid, and add. Okay, so let's do one example of that one real quick so we can see one. So here we have the speed, so this is a rate. Speed in miles per hour of a cyclist at various times. Use a trapezoidal approximation with 6 subintervals to find the total distance. So this distance is the accumulation of speed that the cyclist travels in the 12-minute time interval. One thing that I want to point out, this is in minutes, but speed is in miles per hour, so we are going to need to convert that. Okay, so if we want a total number of miles, we're going to treat these minute intervals as a fraction out of 60 instead of just their values. So we could do that a couple of ways. We could either divide each of these by 60, or since I know I'm dividing everything by 60, I'm just going to put a 1 over 60 in front of the whole thing, like factor that out. If that doesn't make sense, go ahead and do it for each one. Okay, so our total distance, or our accumulated distance, is 1/60th of, and then I'm going to do the area of each trapezoid. So another thing I notice is that each of the intervals here is not the same width. Okay, in our previous example, they were all the same width. They were all 6 hours, so I could just factor the 6 out if I wanted, or I just knew they were going to all be the same. But because they're not, I'm going to strongly recommend that you put another row above the table, and I just call it delta t because that's my variable here, and I'm going to write what the change in each interval is. So here the change is 2, here the change is 3, here the change is 1, here the change is 3, here the change is 1 again, and another 2. Okay, because it's important that I use the width of each subinterval, which are these values, instead of the actual input values. So my input values are not 0 and 2 or 2 and 5 or 5 and 6, etc. It's going to be these distances right here. And remember, those are the heights of the trapezoids because those are these distances here, the horizontal distances between the bases. Okay, so it's going to be the height of each of the trapezoids. Okay, so for the first one, I'm averaging the bases. So these are the base values. So these are the bases. Okay, so I'm going to do 33 plus 25 over 2 times the height of 2 plus, next one going from here to here, 25 plus 27 over 2. That's the average times a height of 3 plus 27 plus 13 over 2 times a height of 1 plus 13 plus 21 over 2 times the height of 3 plus 21 plus 5 over 2 times the height of 1, and lastly 5 plus 9 over 2 times the height of 2. Okay, and then whatever that comes out to be, haven't calculated it, so some number of miles, or you could just stop right there, but make sure you put miles on there. Okay, and because we have this 1 over 60, that is converting from minutes into miles.